Welcome to homework.
Let us we have a wavelength, two wavelengths for first and second collisions emitted during these collisions of photons. So they for the two, this is for section A. So then the wavelengths and B for B. So two photon wavelengths we have here. Let us we have two photon wavelengths. It's lambda 1 and lambda 2. So then we can write lambda 2 as the initial lambda plus the changed lambda, the lambda that is changed. Then we can write the total energy in terms of lambda 1 and lambda 2, hc over lambda 1 plus the energy associated with lambda 1 plus change in lambda. Then I can solve here for lambda. Let's move this here. I can solve for lambda, then this becomes a quadratic equation. Then when I solve for my lambda 1, then the quadratic equation that I get is lambda original and lambda naught here minus 2 plus minus square root of lambda, change in lambda, or original lambda square plus 4. This is square root is up to here, over then of course 2 over change in lambda. Here we have a change in lambda given, which is 130 picometer, 130 picometer, and lambda naught is given as hc over ev, initial energy. Then lambda naught becomes 63. So in this equation we require change in lambda and lambda naught. We can plug these values here. I can plug these values here in this equation, and I can solve for lambda 1. So the lambda 1 I get here for the first photon, lambda 1 that I get here is 87 picometer. So the energy after first deceleration I get here is K energy, initial energy minus hc over lambda 1. Now lambda 1, I can plug those values. The initial energy is 20 kilo electron volt. I can plug, and then hc I have 1 to 40 over 87. We got 87 here. So if I plug these values, then the energy I get here is 5.7 kilo electron volt. And let's open another page. In section C, we are asked to find the energy associated with the first photon. So the energy associated with the first photon will be simply written as Planck constant times speed of light, as usual, our formula, divided by the wavelength of the first photon. If I plug those values here, 1240 over 87 here, then the energy associated with first photon I get is 14 kilo electron volt. Similarly, the energy associated with this second wavelength, which is equal to lambda 1. Sorry, this is second wavelength, not energy. Then I can just substitute those values that I obtained previously, which is 87 plus 130. Then I get this 80 lambda 2, sorry. And then in section E, we are asked to find what is the energy associated with second photon. So the energy associated with second photon will be simply E2 over Planck constant times C over lambda 2. If I plug those values, the 2 which I got here, if I plug it here, then the Hc constant is 1240 again. Then the energy I get here is 5.7 kilo electron volt.